Born from the dramatic dance of fiber and yarn, it defies ordinary and withstands trends. It inspires confidence and compliments, essential to every wardrobe. It follows your every move and curve, an original icon, creating admiration with every stitch. But it's not just a little black dress. It's a garment created with LYCRA fiber, comfort with staying power, unmatched versatility and lasting performance, a fit that doesn't fade, all from a brand you know.
Good morning and good evening. This is Yani Hu from the LYCRA company Taiwan. It's my honor to be the master of ceremony for this webinar today. We're happy to see and talk with you online and hope we can soon meet up face to face when the COVID situation is much under control. During the webinar, we welcome your submission of questions in the chat box at the bottom of the screen. We will answer the questions collectively before we close the webinar. Now, may I invite Jason Lee, our Commercial Director for Taiwan Asian regions, to welcome you all.
Good morning, I'm Jason Lee, Commercial Director of the LYCRA company responsible for Taiwan and Asia market. On behalf of the company, I feel great honor to have our internal guest speaker and the valuable customer from different locations to stay connected in this online meeting. Recently, the LYCRA company has launched a new sustainability campaign, Keep in the Loop with LYCRA. Security is one of the key sustainability focus of the LYCRA company in the planned agenda. As we look to advance not just our own sustainability goal, but also those of the industry at large. In the webinar, we will hear from our speaker, Mr. Hugh Williams, about how we can optimize our sustainability impact by collaboration and through collective effort in the industry. And Ms. Jean Hendiger will share her findings and the knowledge on the topic of the microfiber, which is a subject we concern so much that it is impacting our environment. I hope you will enjoy the time with us and get inspired by today's topic. As the year end is around the corner, may I take the opportunity to wish you all stay healthy and enjoy upcoming festival holidays. Thank you.
Thanks, Jason. Let's turn to Mr. Hugh Williams for his topic, Bringing New Life to Textile Waste.
Hello, everyone. My name is Hugh Williams, and I work for the LYCRA company in Switzerland. I'm responsible for our polyester products and strategies. And of course, needless to say, sustainability has been and will continue to be absolutely central to our plans going forward. It's really an honor to be invited to speak with you today. I'm going to talk about how we can use textile cutting waste to make premium grade polyester fibers for cooling and warming applications, and using them in woven and knit fabrics, and also in insulation and non-wovens, importantly with absolutely no compromise in quality or performance. We brand these fibers as Coolmax fiber for cooling applications and Thermalite fiber for warming applications. You'll hear that we have a range of products already commercial, available at a large scale, ready to use now, so that a true solution for polyester-rich textile waste is now available. Now I'll pause and I'll show you a short video for about 1.5 minutes to give you a short introduction around the technology. Okay, so on the next few pages, I'm going to cover some context into the scale of the textile waste problem that we are facing. The slide shows that the textile waste problem is growing as, first of all, there's more garments being made every year. Most of these garments, around 85% of them, are actually going to landfill. So that's an unbelievable one garbage truck a second of used garments going to landfill. So we are now buying 60% more clothes than we were just 6 years ago, and we only keep them half as long. So as you can see, the problem is just getting bigger and bigger and bigger. This slide actually says what we all know, that we're making an unsustainable strain on our planet. The current pathway, resource consumption, will triple in the next 30 years, and we would in theory need 3 Earths to actually support this if nothing changes. This is really a sobering thought as we think about the future and what the industry and ourselves as consumers are doing. But the good news is that people are becoming aware of the problem and they see the need to change. So indeed, even last year, research showed that 81% of consumers expect brands to do the right thing and to behave more sustainably, whilst 53% of consumers want to improve their own personal footprint in the area of waste garments. And importantly, almost 70% of consumers think that sustainability is one of the top 3 big issues impacting our world today. And then importantly, consumers are actually not just recognizing the problem, but beginning to change their attitudes to shopping. So you can see here, for example, 60% of consumers are willing to change their shopping habits. More than half the consumers already buy from brands or companies that they trust. And maybe not surprisingly, sustainably marketed products are now growing 7 times faster than conventionally marketed items. And already almost 55% of shoppers feel that they're making a difference through the products that they choose to buy. So in summary, the textiles problem is being recognized by consumers, and most consumers already really want to do something. And indeed, so do we in the LYCRA company. We want to do something, as do many others in the trade. So at the LYCRA company, we have a program called Planet Agenda that was launched in 2008 and continues to be our roadmap to the future. Planet Agenda has 3 pillars. The first pillar is corporate responsibility. This is all about doing the right things all the time, creating a safe and healthy workplace, and being seen as a good company to work for or to buy from. The second pillar is manufacturing excellence. This is about making things as efficiently as possible, conserving resources, reducing emissions, and eliminating waste. And our third pillar is about having sustainable products, making fibers with less resources, enhancing their environmental profile, and indeed making fabrics from these which also reduce resource consumption. So what I'm going to do now is change gear and talk about our latest innovations in sustainable products. This is the technology that recycles textile waste, as you all saw in the video, and creates a starting point for circularity in the textiles industry. So this is what we're doing. For the first time, we're introducing cooling and warming products made from textile waste under our renowned Coolmax and Thermalite brands. We're taking polyester-rich dyed and finished cutting waste from selected garment makers as input, and we're turning this waste into premium performance fiber. This creates a starting point for a circular recycling system in textiles. Now, as the technology actually already works with garments, in the future, we're going to partner with brands and retailers to take back garments, therefore really closing the loop in the textiles cycle. So how does this work? As I mentioned, we're basically collecting dyed and finished cutting waste. We're depolymerizing this and cleaning the waste, and then essentially making virgin quality chip again for making fiber and selling this back into the textiles manufacturing chain. And as I said, in the future, what we want to do is to use the same technology to deal with post-consumer garment waste. But we can only do that when robust textile collecting and sorting systems are in place. Whilst this is our goal and a shared goal of many in the industry, we must not forget that pre-consumer waste is a huge problem, and probably one that is not so well recognized. For example, if one garbage truck of used garments goes to landfill every second, and if you generate 20 to 30% cutting waste when you make a garment, then one truckload of cutting waste must be going to landfill or to waste every 3 to 5 seconds. So that in itself is a huge problem in its own right. And it's one that we think we can tackle right now without having to wait for garment collection and sorting systems to be put in place. So when we use this new recycling process and look at it from an LCA perspective, probably the highlight is CO2 reduction. Net in the production of semi-dull polyester chip, CO2 reduction is around 25% less versus making the equivalent virgin polymer chip. Plus, of course, you keep existing material in cycle, making premium grade, essentially virgin quality products with all the aesthetics, quality, and durability benefits that you would expect. So in this section, we're going to talk about specific fiber products that we're making and which are now commercially available. I'm going to begin by talking about Coolmax EcoMade fiber, which we're making by this new process. So on the left-hand side of this chart, you'll see what consumers expect from cooling fabrics. They want breathable fabrics that keep you cool. The fabrics need to feel good, be lightweight, and move like a second skin. But they must also be durable. Fabrics also need to be versatile. It's not just for high-impact sport, but also for summer days, warm offices, work environments, and the like. So increasingly, products have to be versatile and also sustainable. The right-hand side of the chart shows what we're doing. We're creating fibers with special cross-sections which increase the surface area and which are designed to spread moisture and evaporate moisture quickly, allowing it to evaporate as quickly as possible. The spreading effect helps keep you dry, and the key feature is really evaporation, as it's the evaporation of moisture that cools you down. Think about rubbing your hands with alcohol solution and how cold that feels. That's how Coolmax works. The evaporation gives the cooling Coolmax. And really the point here is you can now have all this performance in a product made from textile waste with absolutely no quality, performance, hand or optical compromises. This chart is talking about the performance testing that we do, not just in fiber, but also in fabric, to ensure that the product really works in a garment in store. We perform a large battery of tests on these fabrics to ensure that the product actually cools in practice. We also check the performance versus other cooling products in the market. And we typically find around a third of the products that you will find in store, which are marketed as cooling products, don't actually do what they claim. They often fail to wick, for example. Durability in our case is assured because this is a fiber-based technology, not a finish. And on the sustainability side, we have various certifications endorsing the sustainability credentials of the products. On this next page, we talk to Coolmax brand value. And there's a lot of data here, but in summary, it's one of the top 3 cooling brands globally. And it gives brands and retailers an opportunity to leverage this equity through to purchase preference, even at premiums versus generics. This huge brand equity is a central part of our value proposition and is very, very appealing to many brands and retailers to help endorse the quality of their products. So now I'm going to switch gear and talk about Thermalite, which is really the warming partner going with Coolmax. So again, on this chart, on the left-hand side, we have the consumer expectations for warming fabrics, or warming technology in apparel. Obviously, consumers want warmth, of course, but they also want it to be lightweight and to feel good. They're looking for durability and, again, versatility, not just for climbing Everest, but garments that you can use out and about in town and in the office or at home on cool winter evenings. And again, increasingly, sustainability credentials are becoming absolutely central to consumer needs. On the right-hand side of the chart is our solution, providing lightweight warmth for these consumers. Indeed, Thermalite technology is made from hollow fibers, mimicking the fur of polar bears. The hollow fibers trap more air per unit weight than the solid fiber, so you get more warmth per kilogram of fabric. And as is the case with Coolmax eco-made fibers, Thermalite eco-made fibers from textile waste provide the same quality and performance as their virgin counterparts, whether you use them in knits, wovens, or now in non-woven insulations. So again, as with Coolmax fiber, we routinely test the fabrics, not just the fibers, to ensure that they're delivering excellent warming and related performance, such as dry time, breathability, packability, and the like in fabric form. Durability is also assured as the technology is fiber-based. And in short, again, we're testing to ensure that the brand promise is delivered in fabric, linked again to those sustainability credentials, such as GRS and Urcatex. And again, on brand value, you'll see that the Coolmax is the Thermalite brand is one of the most recognized brands globally for warming technology, again, driving strong consumer purchase preference. As in the case of Coolmax fiber, the Thermalite brand is a great asset and endorses the performance of the products to consumers who are buying them. So as I said, these textile waste products, they're not a dream. They are available, they're available now for broad commercial use in staple form, in filament form, and in fiber fill forms for all common textile processes. Just to finish up, I've got just 3 charts on our very latest innovation, which we're launching today. Thermalite eco-made insulation made from textile waste. These insulations have proprietary constructions and fiber recipes, and they're designed to give outstanding performance, industry-leading performance, whilst the recycled content also gives outstanding sustainability credentials. This page is a little bit complicated, but gives you a snapshot of the kind of performance you can expect with Thermalite eco-made. Top chart is for thin insulation, so that's the kind of insulation that might be used in a lightweight jacket or a glove or similar. The orange bar that you can see is the product made from Thermalite textile waste. And you can see it has the best warmth per unit weight versus leading industry competitive products. The same is true for the mid-loft products. That's the chart on the top right. Mid-loft products being used for puffer jackets and the like. And again, Thermalite in the orange bar there, giving great warmth per unit weight. The bottom chart shows the recycled content of these competitive products. The first 2 bars are Thermalite eco-made items, both with 85% content. The lower bars, the other bars talk about competitive products, and you see that they typically have much lower content, maybe around 50% or so. So in summary here, the industry can have uncompromised performance with outstanding sustainability credentials, helping to deal with that textile waste problem. The next page is just an overview of the LYCRA company's eco-made portfolio. Some of you will know we have LYCRA eco-made fiber made from pre-consumer textile materials. We also have LYCRA T400 eco-made fiber. This is a polyester stretch fiber, which is made mostly from bottle resin and bio-based materials. And of course, we have Coolmax and Thermalite eco-made items, which can be made 100% from plastic bottles or now from textile waste, as we've just discussed. So I hope you will join us on our mission to kickstart circularity in textiles through our Coolmax and Thermalite textile waste initiatives, working together to keep the waste out of landfills. If you have questions or want to start a development, please just send me a note at hughwilliams@lycra.com or talk to your local LYCRA company representative. Thank you for listening to me today. But just to finish, as a summary, we have a very short video that you can look to just to remind you of the key points of the talk. Thank you very much again, and goodbye.
Thanks, Hugh. Let me introduce our next speaker, Ms. Jean Hegedus. Jean is our Sustainability Director with over 35-year experience in the textile and apparel industry, and has been recognized by 2020 Rebate 50 honoree as one of the most influential leaders in the global denim industry. Now, let's welcome Jean Hegedus.
Hello. It's a pleasure to be here today to talk to you about this important topic, microfibers. And as you know, this is something that's very important in our industry today. So let's take a look at some different areas where we want to dive into. The first is really around why do we want to talk about microfibers? I'll talk a little bit about some definitions. Where are microfibers found and what impact are they having? And then finally, what is the industry doing? What is our company doing? And what can we as individuals do to address this important issue? Now, microfibers is a topic that really elicits many different points of view. And what we are trying to do is clear up some of the misinterpretations, miscommunications that are out there. And one of the biggest ones is that microfibers are really the primary source of plastic pollution in the ocean today. Now, that's actually not true. We are stressing our oceans in many different ways. Ocean temperatures are rising, which is causing acidification. It's also affecting coral reefs. There's chemical pollution, there's overfishing. The salinity levels in the ocean are rising, and there is waste. That waste is mostly plastic, but not necessarily microfibers. And microfibers are also being sort of vilified in the media. If you look at the picture that's in the upper corner here, what you see is a lot of plastic that's floating in the ocean. But the caption that goes with the picture says the problem with microfibers, okay? And this was from a publication called Fashion Takes Action. So although microfibers are a very serious problem, it is not the biggest contributor to ocean pollution. And microfibers consist not only of synthetic fibers, but natural fibers as well. And we'll talk more about that in a little bit. So let's just go through a few basic definitions. First, it's helpful to understand the difference between large plastics and microplastics. So microplastics are generally plastics that are no more than 5 millimeters wide by 5 millimeters high. And large plastics are larger than 5 millimeters. And then what we see is that there are primary and secondary plastics. So primary plastics refer to how does the plastic, what form is it in when it enters the ocean? So if it's more than 5 millimeters, it's defined as a large plastic. It can be a microplastic if it's smaller than 5 millimeters, or it can be microfibers, either synthetic or man-made. Secondary plastics basically are those that enter the ocean as large plastics, but then they break down over time into that 5 millimeter or smaller piece. Now, what further sort of complicates the situation is that within our industry, there are even different definitions of that mean totally different things around microfibers, right? So the original textile definition was that a fiber that was less than 1 denier per filament, which is about 100 times finer than a human hair. So you see in the picture there's a cleaning cloth, and a lot of cleaning cloths are made what we call with microfibers, right? But these are not really the type of microfibers that we're talking about today. what we're talking about is fibers that shed from our clothing or other textiles, and that can be during the production of those fabrics or garments. It can be during consumer use, or it can be at the end of life. And basically, these fibers end up as pollution in the environment. What's important to note is that they can be both synthetic or they can be natural fibers. And as we said, it's usually less than 5 millimeters, but there are some definitions that vary. And synthetic microfibers are considered a form of microplastic. So microplastic is the larger category, and microfibers is a part of it. So where do we find microfibers? Well, today we estimate that there are over 340,000 metric tons of microfibers that are accumulating on the land and in the oceans and other bodies of water. They're basically found everywhere. They're in the air, in the water, in fish, in fruits, in vegetables. We even find them in things like beer and wine. It's important to note that at the present time, we really don't know what impact microfibers have on our health or on the health of animals. But there is a lot of research that's ongoing to try to determine that. So where do they come from? Basically, all different types of textile and apparel products. So it can be fashion apparel, it can be automotive textiles, it can be outdoor apparel, home textiles, geotextiles, and even personal care products. Now, when we think about microfibers, what we often hear is we think of it as an ocean problem, right? But as we just said, they're found, now we're starting to see that there's actually just about as much or maybe even a little more microfibers on land as there are in the ocean. But let's take a look first at the ocean situation. So if we look at total plastics, not microfibers, but total plastics that are found in the ocean, that's about 12 million metric tons a year. And 9 million of that actually comes from the land into the ocean. And 8 million metric tons of the 12 are large plastics. And about 1.5 million tons are microplastics. And then what we see is that actually only 20% of that 1 million tons, actually 190,000 tons, are microfibers. So textiles, what comes from textiles is really 190,000 tons. Now, that's a lot. It's certainly, we're certainly not trying to say it's not an issue. However, it is not, as you can see, it's a relatively small portion of the overall microplastic problem. Now, this is an interesting study. This was just recently done by Science Advances, and they went around to 6 different ocean basins around the world. You can see there all the different oceans where they collected and tested samples. And what they found was that only 8.2% of the fibers were synthetic, with most of them, almost 80%, being cellulosic, and another 12% being from animals. So when you think about the fact that 2/3 of the fiber that gets produced in the world today is synthetic, and only 8% from this particular study of what was found in all these different oceans was actually synthetic fibers, there's a big mismatch there between how much we're producing and how much is actually, in the ocean. And so what scientists are beginning to think is that natural fibers actually are not biodegrading, and that they've been there probably for quite some time, because the amount of natural fibers that we're seeing in this study is much higher than the amount of natural fibers that you would expect to see based on how much is being produced. This was another study from Canada that was done in 2020, and they looked at actual microfibers found in different lakes and in basically around around Canada. And what they found was that of all the particles that they picked up that came from man or human intervention of some sort, that nearly 90% of them were microfibers. And what they found was that depending on the lake or the particular area, anywhere from 21 to 51% of those microfibers were from cellulose. And of the ones that were cellulosic, 40 to 57% were denim. They were from jeans, right? And so what we're starting to see is that, jeans obviously are a very popular garment worldwide, and that a study done on Levi's jeans recently showed that one used pair of jeans, every time it goes into the wash, it can shed about 50,000 to 56,000 microfibers per wash. So that gives it a pretty big, geographic footprint. So again, this is really showing that microfibers are not just synthetics, that there is quite a bit out there with natural fibers. And so we have to try and keep that, in context. Now, as we're looking at different studies, there are a number of things that we need to watch out for. Microfiber pollution is being studied by a number of different organizations, and depending on the research methods, the definitions, the analysis, the results vary very, very widely. And so some of the things that we need to watch out for are how did they capture the samples? Usually it's done through a mesh on a trawler. So how dense was the mesh? What was the trawling method that was used? Where did they take the water samples from? How far was that from a likely contamination source? How did they define microfibers and differentiate them from microplastics? What is the depth in the water? How deep did they go? We know, for example, that there was actually a pirate ship that was sunk 166 years ago. And when investigators went down and found this in the ocean, one of the things that they found was a 100% cotton shirt that was still intact that was over 166 years old. So, at the bottom of the ocean, temperatures are quite cold, and it just goes to show that really degradation doesn't really take place in those kinds of temperatures. So most fibers are going to shed, whether they're natural, they're synthetic, they're man-made. All fibers basically will shed during wear. Some are more prone than others. Some different types of fabrics are more prone to shedding than others. So some of the things that we can look at are, the fiber type. Is it staple or is it filament? Staple tends to shed more than filament does. What was the fabric type and the quality, and how tightly was it woven or knit? Dyeing and finishing. Was it brushed or sueded? That's something that can also cause fibers to break off. How old is a garment? We see that older garments tend to shed more than newer ones. How was the garment worn? Is it, was it workwear versus leisure wear? Is it worn under conditions where it would see a lot of abrasion, for example? And then how is it washed? And are you washing it in, what type of machine, a front loading machine or a top loading machine? What's the temperature? Is it cold water or warm water? And what type of, even the type of laundry detergent can have an impact. And then of course, how is it dried? Tumble drying in a dryer actually will cause, more fibers to break off than if you're just hanging the clothes out on the line to dry. So let's shift a little bit to talking about microfibers on land. At the University of California, one of the studies that was done found about over 175,000 metric tons of synthetic microfibers ending up on the land each year, compared to about 167,000 metric tons in the water. So that's suggesting that there's even more microfibers on land than in the water. And sometimes actually microfibers, when they go from the wastewater treatment plant, rather than going into the water, some of that gets retained as sludge. And so it can end up in things like, crops as fertilizer, or it can get buried in landfill. There was also a study done by the University of Beirut, and they looked at microfiber accumulation in 3 indoor sites and found very significant amounts of microfibers, but they found that just over a third of those were synthetic. So again, you're seeing a lot more natural fibers. So what is the impact that microfibers are having? Now, the truth is that microfibers have probably been digested by humans for centuries. And so you may be wondering, well, why are we just starting to hear about this now, in the last few years? And really, it's been because we've been able to actually test and capture this. But what we are seeing is that, most of the studies that are out there are focusing on microplastics. And remember, microfibers is just a part of that. But there are 2 main areas of concern. The first is really about, is it that microplastics can cause a blockage in the stomach of small creatures like plankton. And they can block the gut, and that can cause death in the case of these microplankton, which are very important to the overall ecology in the ocean. The other area of concern is not so much the fibers themselves, but the fact that they're dyed. I mean, most of the clothing, right, that we wear, it's been dyed or it's been printed, and then some of these dye agents can actually act sort of like sponges and attract toxic chemicals. And then that in turn can get ingested into the food chain. So we believe that actually the microfibers themselves are not necessarily a serious health impact to humans, but because of the chemicals that they may be carrying or may attract, that could potentially be an issue. So there is a lot of research that's going on in this area, and that's the good news, right? The research is being done, and we'll have to see really how that research comes out. Okay, so let's talk a little bit about what's being done in the industry to address these issues. Most of the work that's been done on microfibers really started back around 2013. And in 2015, Patagonia, they were one of the first brands. They actually partnered with the University of California on some of the first research on microfiber shedding. And then the European Outdoor Group formed what's known as the Microfiber Consortium. And this is really looking at how can we develop solutions to minimize microfiber shedding in the environment. And one of the things that we talked about before is the test methods are really important. So this group worked on trying to come up with a standardized test method. They have conducted research on the various shedding behaviors of different types of fabrics. And trying to get that consistency in terms of the research is really something that's very important. Now, in addition to the European group, there's also been some additional industry associations. The one is the Cross Industry Agreement, or the CIA. They are also trying to develop some international methods, standard methods, to identify and quantify microfibers in the water and the environment. So the Microfiber Consortium is working with them, as well as the AATCC, American Association of Textile Colorists and Chemists. There's some outdoor brands like MAC, REI, and Patagonia. They're working with the Vancouver Aquarium to understand where microfibers come from and to try to track them. So there's a lot of different trade initiatives that are going on. So what is the LYCRA company doing about microfibers? First of all, what we're trying to do is really keep abreast of the topic and review a lot of the research that's being done out there, and try to provide accurate and truthful information based on what we see from the research. We've talked a lot about natural fibers and about polyester. Of course, the LYCRA fiber, our key product is LYCRA elastane. And we don't hear a lot about elastane in terms of microfiber shedding. We do believe that it probably does shed, like all other fibers do. However, because it's a continuous filament, we believe that it sheds less than, say, a staple fiber. And also the fact that it is the minority component in a garment. We're not expecting to see significant amounts of LYCRA fiber shedding versus the other fibers. We do, of course, offer products like our LYCRA Extra Life, which can help keep LYCRA from breaking down and potentially reduce fiber shedding because it lasts a lot longer. So what can we as individuals do? Some of the things we can do is first try to wash our clothes less frequently. The more we put our garments through the wash, the more they're going to shed. And if you use a full laundry load, you get less friction, and that helps reduce shedding as well. So also the temperature of the water, using cold water and washing for the shortest cycle is very helpful. If you can use a front load washer, that actually helps reduce the amount of shedding. And then you can potentially put an external microfiber filter. So in clothes dryers, of course, we have a filter that catches a lot of the lint. And there are some countries that are looking at legislation that would require new washing machines to have these filters that would help trap microfibers in them. But for the moment, what you would have to do is actually buy an external filter. The other thing is that there are these laundry balls that help attract the microfibers to them, and washing bags that can try and trap them as well. So just to sum up, microfiber pollution is an important issue, but we need to consider it in the context. Often microfibers are sort of said to be, the biggest polluter in the oceans, and that simply isn't true. So there is a lot of microplastic in the ocean. That is an issue. And microfiber is a small part of that. So we certainly need to do everything possible to try to address the issue, but we also need to try to keep it in context. It's also not confined to polyester or synthetic fibers. In fact, the more recent research is showing that we're seeing a lot more natural fibers actually in the ocean and on land than we are seeing of synthetics. And now one of the main concerns, of course, is around microfiber shedding and that getting into the food stream. We don't know at this point whether microfibers actually pose human or animal health risks. Certainly microplastics and large plastics, they have been shown to cause harm to animals. But most probably, we have been ingesting fibers for a very long time, as long as we've probably been wearing clothes, is what scientists believe today. There are fibers out there that claim to be biodegradable in ocean conditions. There are some tests by different labs that try to simulate ocean conditions. We would just say that is a very difficult thing to do, to match temperatures in the ocean, to match the movement in the ocean, etc. And finally, we believe that LYCRA fiber, we do anticipate that, like all fibers, it does shed, but because it's the minority component in a garment, it has not been really an area of key concern or focus at this point in time. So let me stop there, and I think now we're going to open up the session to questions. Thank you.
Thanks, Jean. Next, we will have 10 minutes Q&A session. Besides Jean, Felix Hu, our Global Technology Manager for Branded Specialty Polyester, is also staying with us to address the questions that we received from you.
This is Felix. I'm in charge of the Coolmax and Thermoline Fabric, the technology service. Nice to meet you online. Back to you.
Thanks, Felix. Now we have the first questions, which is just curious on what is the test method to prove the thermal performance of our thermal light.
Okay, thank you, Yannick. So basically for our Thermoline fabric, we have a couple different applications. So included the fabric, which is included knitting, woven, denim, socks, and so on. And another one is insulation. But basically for the thermal performance, we are conducting the thermal resistance, which is based on STM D1518 or the other ISO 11092 different test methods, then to verify the performance level. So in case if you have any interest, you want to know more, then we can have our technical service person to contact with you. Back to you, Yannick.
Next one, we will have one question for Jean, which is, could natural fiber be biodegradable in land?
So natural fibers, every fiber does eventually degrade. It's a matter of time and it's a matter of conditions, right? So today, the unfortunate reality is that 85% of clothing ends up in landfill at the end of its life. And in most landfills, you don't have very good conditions for degradation to occur because there's a lack of oxygen, a lack of sunlight, and a lack of water, all three of which are needed to encourage degradation. So the fibers will eventually degrade, but for example, for a garment, for example, to be labeled as biodegradable, in the US, the FTC says that it has to degrade 100% in the most prevalent form of disposal, which would be landfill, within 12 months. And we really haven't found even natural fibers that can degrade within that 12-month period. It tends to take more like, 3 years, 4 years typically for a garment to degrade in that, even with natural fibers, in that type of landfill situation.
Thanks, Jean. The next question will be for Felix, which is, where can our factories get their textile waste from? Asking because the other supplier feedback that there is not much textile waste for them to work on.
Okay, thank you, Yannick. So basically for the, in terms of the verification, we have a couple different processes. Either we can provide our transaction certificates, through the GIS process. And another one will be, by using, we have the traceability in the yarn. But in terms of the cutting waste that we collect from, that is majority from cut and sew mills, especially for those garment manufacturing, located in those countries, for example, in China or other countries. So I think for that piece, we can leave it, we have a whole slide of the presentation, then we can have some, kind of update to you if you have interest.
Next one. How much percentage of the elastane can be recycled? Any new developing news from the LYCRA company can be shared. Jean.
Sure. So typically garments that contain, let's say, 1 to 2% elastane can be recycled, can be mechanically recycled. So if you have, say, a pair of jeans that's 98% cotton, 2% LYCRA, most mechanical recyclers can handle that. When you get into, let's say, 2 to 10%, many of those garments can be also recycled, but not generally back into garments. Usually those types of, at those contents, those garments would end up going into things like insulation for buildings or interiors of insulations for automotive seats or wipes. The most challenging part is when we get into garments that have high LYCRA content and typically would be blended with nylon. So here we really need to look at chemical recycling. And the LYCRA company is working with a number of recyclers. We believe that, being able to recycle garments at the end of life is really a very, very important, it's something that we as an industry need to do. And so it's a high priority for our R&D team. And we are working, as I said, with a number of recyclers on chemical recycling, so that within the next year to 2 years, I think we're seeing some promising results now, and we hope to be able to bring something commercial within the next 1 to 2 years.
Thanks, Jean. One more question for you. Speaking of textile waste recycle, seems like if it is the fabric with elastane, is it difficult to recycle?
Yeah, so as we just discussed, there are a number of different factors that will determine whether it can be recycled. One is the content of the elastane. So at low contents, generally not a problem. At higher contents, it becomes more difficult, and that's where we have to look at the area of chemical recycling, and working with different technologies within chemical recycling to be able to separate the fibers and then take that LYCRA back, not as a waste stream, but as a recovery stream.
Thanks, Jean. The next question is that for the Coolmax from textile waste, what's our method of recycling? Is it mechanical or chemical? Felix.
Okay. In terms of the recycling process for our new textile waste, actually we are based on the 100% chemical recycle process, which is patented. So far, I think that will be different from what we are using for our bottle recycle currently used. That is like a mechanical recycle, which is different. And that's the reason, in Hugh's, the previous slide, you can see by using this chemical recycle process, the yarn or the fiber can deliver the same performance or the look like a virgin fiber or yarn. So that is the key differences. Back to you. Yeah.
Thanks, Felix. Next one. Does LYCRA company have plan to enhance biodegradation for microfibers and microplastics generated by LYCRA once it happened in the ocean? Jean.
Sure, thank you, Yannick. So as we just talked about in the presentation, biodegradation in the ocean is very difficult for for a number of reasons. One being, does the fiber float or does it sink? The temperature of the ocean, the movement of the ocean. So although there are tests that labs have that try to simulate ocean conditions, it's really very difficult because those conditions vary so widely. So we are looking at potentially, are there certain additives that could be used with some of these fibers that could potentially enhance degradation or reduce the biopersistence. So that is something that we are looking at for the future.
Thanks, Jean. The next two questions I want to combine for Felix. The first one is that speaking of our chemical processing, will the chemicals we use to clean the plastic waste and pollute more? And then the second one, recycle from plastic waste is the trend, but how we ensure the safety aspect in terms of chemical toxicity and dyes use of the plastic waste? Felix?
Thank you. Actually, this is quite complex question. So in terms of the whole process, actually for the manufacturing, they also got different certificate, based on different like ISO or other process. But in terms of the process, especially for this chemical recycle, we are using glycolysis, which is, we are melting the textile waste that we are collecting from. So if you look at the whole chart Hugh, just presented, we can show you more, in terms of the detailed process. But, in terms of the toxic wood, we also testing the yarn based upon our OQTex requirement, as well as the SVSC, those kind of the test result. We can prove, either our yarn or the product we are selling is under control. So that is the key kind of the question that asked back to you. Thanks.
Thanks, Felix. The next one, knowing LYCRA eco-made offerings will reduce around 25% carbon footprint. But what's the benchmark for this 25%? Is it from bottle recycle or from virgin polyester? Felix.
Based on our LCA, the result, actually this is compared with virgin. So the benchmark is virgin fibers. Back to you.
Thank you. Next one. Can you please share LYCRA's current plan for bioelastane 162R? Jean?
Sure. So back in 2014, the LYCRA company was we were DuPont at the time, but we were the first to introduce the world's first bio-based elastane. And at that time, I think there was a lot of initial excitement about the fiber. But what we found was people were they were still really looking for solutions for some of the main fibers like cotton and polyester. So now people have found those solutions. We have, of course, organic cotton, and we have BCI cotton, and we have recycled polyester. And so there is more interest in looking at things like bio-based LYCRA fibers. We are actually working with a company that will be breaking ground on a plant in Iowa, which has been recently announced, to make the bio-based chemicals that go into, one of the chemicals that goes into making LYCRA. So we do have a plan to convert from, traditional fossil-based LYCRA to renewable. And that will be, that process will start to see pilot quantities probably in 2023 and commercial quantities in 2024.
Thanks, Jean. The next one. Is there any textile waste claim on Thermolite hand tag or any certificate to prove it is from textile waste? Felix?
Okay, to answer this question, we, in terms of the new technology platform for our EcoMate, we have our standard, we have the yarn type, the yarn denier or filament in order to be identified. Then we have content requirement. Once the fabric, can be past our Thermolite or Coolmax, the new EcoMate platform standard, then we will get the hand tag.
Thanks, Felix. The next one, how about the capacity of Coolmax and Thermolite from textile waste? Felix.
Okay, to answer this question, so far we have new plan is ongoing, but current the capacity will be around 20 to 30 kiloton at this moment. So in terms of the filaments and the staple will be all included.
Thanks, Felix. I believe we are having the last one as it is moving to the end of this webinar. The last one question we are taking is that which one is better performance-wise, Coolmax EcoMate from recycled bottles or from textile waste? Felix.
Okay, so basically for the EcoMate platform, we are using two different technology, which is from bottle recycle as well as the textile waste. So no matter which one, actually our Thermolite, our Coolmax or Thermolite EcoMate platforms, the standard are the same. So no matter, as long as you are using the qualified yarn, we list it in the standard, and the Coolmax or Thermolite fabric can be past our criteria, then the performance will be same. So that means, no matter which platform you are using, so basically for the Coolmax or Thermolite, the fabric performance all can be guaranteed. So that is our key promise of that. Thanks.
Thanks, Felix. And also thank you, Jean. As we are moving to the end of this webinar, would you please take a few minutes to scan the QR code here? And please complete the questionnaire to help us improve the experience of our next webinar. Again, we thank you for your time today and appreciate your support to our company, especially many of you who have been with us for so many years. On behalf of the LYCRA company, I'm wishing you and your family all the best. Bye-bye.